Imagine that you're a salesman who sells books. You have a list of 10 cities that you want to visit and sell your books to. You know the distance between each pair of cities, and you want to find the shortest route that allows you to visit each city exactly once and then return to your starting point. This way, you can save time and money on your travel expenses. However, finding the shortest route is not as easy as it sounds. There are many possible routes that you can take, and each one has a different total distance. In fact, there are more than 3.6 million possible routes that you can choose from. How can you find the best one among all of these different routes? You can try to check every single possible route and compare their distances, but that would take a very, very long time. Even if you could check one route per second, it would take you more than 40 days to check all of them. And what if you have more than 10 cities to visit? The number of possible routes would grow exponentially, and it would become impossible to check them all in a reasonable time. This is the essence of the traveling salesman problem, or TSP for short. It's a classic example of an optimization problem where we want to find the best possible solution among many possible solutions. Optimization problems are very common in many fields, such as engineering, economics, biology, and artificial intelligence. However, they are also very hard to solve by conventional means, such as brute force or heuristics or traditional algorithms. That's why we need genetic algorithms, a type of optimization technique that mimics the process of natural selection. Genetic algorithms can help us find good solutions to the TSP and other complex problems in an efficient and creative way. Hello, and welcome to this video where we're going to learn about genetic algorithms and how they can help us solve complex problems in artificial intelligence. Genetic algorithms are a type of optimization technique that mimics the process of natural selection. They're inspired by the ideas of Charles Darwin, who proposed that living organisms adapt to their environment through natural selection and inheritance. Genetic algorithms work by creating a population of possible solutions to a given problem, and then improving them over time by applying some genetic operators. These operators are selection. This is the process of choosing the best solutions from the current population based on their fitness score. The fitness score is a measure of how well a solution solves the problem. For example, if we want to find the shortest path between two cities, the fitness score could be the inverse of the distance. Crossover. This is the process of combining two solutions to create a new one. This simulates the biological reproduction of organisms where offspring inherit some traits from both parents. For example, if we have two solutions that represent paths between cities as sequences of numbers, we can swap some numbers to create a new path. Mutation. This is the process of randomly changing some parts of a solution to introduce some variation. This simulates the biological mutation of organisms where some genes change due to errors or environmental factors. For example, if we have a solution that represents a path between cities as a sequence of numbers, we can change one number to another. By applying these operators regularly, genetic algorithms can explore a large space of possible solutions and find the ones that are optimal or near optimal for the problem. Genetic algorithms are useful for problems that are hard to solve by conventional methods, such as problems that have many variables, constraints, or objectives. Some examples of problems that can be solved by genetic algorithms are the traveling salesman problem. This is the problem of finding the shortest route that visits a city and returns to the starting point. This is a classic example of an optimization problem that has many possible solutions and is a hard problem to solve by brute force heuristics. Imaging processing. This is the problem of manipulating images for various purposes, such as enhancing, compressing, or segmenting them. This is an example of a problem that has many variables and objectives, such as quality, size, or speed. Genetic algorithms can find good solutions by evolving images that satisfy the desired criteria. Machine learning. This is the problem of learning from data and making predictions or decisions based on it. This is an example of a problem that has many parameters and constraints, such as accuracy, complexity, or interpretability. Genetic algorithms can solve and be good solutions by evolving models that fit the data well and generalize well to new data. These are just some of the many applications of genetic algorithms in artificial intelligence. Genetic algorithms are powerful tools that can help us solve complex problems in an efficient and creative way. They're also a fascinating example of how nature can inspire us to design better algorithms. Thank you for watching this video. If you liked it, please give it a thumbs up and subscribe to our channel for more videos on artificial intelligence topics. See you next time.